Hello friends, welcome back to the bench. Today we have a multimeter. As far as I established, this is 1982 digital multimeter from Data Precision, property of IBM. Since they went out of business, I don't think they'll mind. Let's see if we can figure out how it works and maybe get it to work again. Let's see. Okay, here it is. It is nice, I think, leather packaging, boxing, casing. As you open it, we have a 12 volts, no, 8.7 volts. 8.7 volts, 8 watts, 160 milliamps. And this is all glued, so no way to disassemble it. The connector, 2.5 millimeter jack, not regular sound jack. Here's the unit, and we have some stuff here. Let's see. There's a fuse, COM, okay, and I assume that's how it works, and yeah, and you put your bananas here. And there you go. And it has a little stand. Nice. If it works, maybe I can even use it. It doesn't turn on. It was calibrated in January 1982. I wasn't born yet. I was born later that year. So calibration was due in 1983, so I think it's a little bit past due. Now it's pretty heavy, there are batteries in there, and I could just connect it through this power supply and start charging it, see what it does. But if this has been sitting for 4 decades, let's see what's inside first. Oh. And we have calibration stuff that has been calibrated 40 years ago. And we have a battery here. There. Okay, that's what I wanted. On the inside, you can't really see much, but yeah, plenty of analog and electronics there. We'll see some old capacitors, probably germanium diodes. Good stuff. Alright, now is the battery alive? It doesn't turn on, but if there's at least any voltage on it, and there's 0.6, that's not bad. So this is positive, this is negative, and we have 1, 2, 3, 4, 5, 6 times 1.2 volts, maybe 1.5, and that's roughly around 9, right? 8.7. So let's see if the battery will want to accept some current. How much of that current? Let's set it to 6.5 volts. Let's bring the current all the way down. Maybe adjust the camera so you can see something. Okay. Let's see. We can push 700 milliamps. Let's reduce it a little. 400. Let's do around 400 milliamps. And so the positive was this one. That's good. It's not good, so let's get that. Okay, and it's grabbing the entire 395 milliamps. The voltage is slowly rising, so the battery is charging. So this battery will likely wake up after a little bit of charging. Okay, the voltage went up to the supply level and the current is slowly dropping now. So it's charging to that level, but it needs to be charged to the level of around 8-9 volts. But first I just want to wake it up, then I'll put it back in the device and try to recharge it using the power supply. But first, maybe I'll check if the power supply even works. Okay, so 6.4, that's good, 7 volts. Not 7 volts perfectly. We're trying to copy, so there's other little capacitance or capacity left in those batteries. These are just another because I think they exist in the 80s. Maybe they don't, rather than surprise. So maybe some form of SLA. Alright, so the battery is awake now. Let's make sure it's turned off. Now let's replace this for two reasons. First, let's hold it. That's probably what holds the battery. Second reason, I don't want to lose any screws, parts, or anything. This is not exactly a device you can randomly just order parts for. Let's see this. Let's see, it's actually giving us that voltage. So the positive is here, here, makes sense. But none of voltage 11.4. Well, this is transformer, so essentially I'm going to load the voltage, so it should be better. So that's not how much energy is consuming. But nothing's happening. So the battery might still be too dead, or the charging circuit is not working, or all of the above. Alright, that's what it looks like. So the input goes here and here. The white cable goes here, black cable goes there. That should be easy to remember. We have some big chip over here. 2010, 58, some kind of logic chip, I guess. Okay, so this will probably need recapping, but let's solve the problem of power. So let's again connect some power to it. There's RT reverse diode, probably to protect from interpolarity. So let's follow that. Right, so this is plus, that's 6 volts. Like so. Take the resistors and let's connect them up. So what goes here? 1980 solar. Okay, so let's do this one. So this is positive. Okay. It's grabbing 390 milliamps, which is my limit. So we have a short. It's not a diode. I'm trying to think hot yet, but it's just moving away. Okay, so it's a dead short in both directions. So now we just need to find a shorted element. It's all done by the way. You trace the circuit. There's a cable going here. That's the ground. So it's connected here. I'm very unfamiliar with this. I think I should be short here. I just open it maybe. Oh, it's outside board. Okay. I have no thermal camera, so we need to do it the old-fashioned way. Okay, so this is my final diagnosis of this device. So when I supply the input voltage, that is what, like 8 volts or whatever, on the battery terminals I get, I don't know, like 200 millivolts. So the charging circuit is faulty. The battery will not charge. However, that doesn't mean that the device is not working altogether. Let's get rid of this resistor here. Because when I supply voltage directly to where the battery would be, so basically now the device is essentially powered from the battery, ignoring the charging circuit. Alright, I don't have any shorts or anything. When I do turn it on, I get 26, 27 milliamps, 28 after a little while. So it seems like it's turning on, but I don't see anything on the display. So now, other than the charging circuit that is faulty, it could also be responsible for powering the display. So maybe the power is gone, or the display itself is damaged, or I don't know, probably, or just burnt out. Who knows? But this is where I stop with this, and here's the reason. The board. This is old school boards. So this is all, drawn by hand, and then using, photography, you would replicate those boards. But this is all, these are not straight lines. It's all hand drawn. The board is double-sided, right? The components are packed together very tightly here. So reverse engineering the circuitry of this device would have been quite a challenge for me. Very time consuming for all those reasons. So I am not going to attempt to repair it. I'm going to put it back together as it was, resolder those 2 wires that I desoldered, so I can put it back in the case. And basically, if I don't know, actually, if there is anyone that would like to take on the repair of this device and record a video and publish it, and let me know, I'll send it to you. I get it for free, so either way, I wasn't really planning on using it. I was thinking maybe I can, after I fix it, maybe I can donate it to some museum or school or something like that. But there's not much value in it when it doesn't work. Even as a museum piece, it's not quite old enough to be museum worthy. So only if it's working, it's actually performing, then it would have some sentimental value. Other than that, it's just a piece of junk that doesn't work. Completely useless to everyone other than to just look at it. Alright guys, if anyone is interested in repairing this, let me know. I'll ship it off to you, and I will gladly watch the video how you repaired it. Other than that, it's going back to the shelf, and maybe I'll just sell it on eBay if no one is interested in fixing it. Maybe I can find someone on eBay that would be. Anyways, thank you very much for watching, and I shall see you in the next one.